Okay, use the graph to answer the question, which series of transformations correctly maps polygon A, B, C, D, E to polygon A prime, B prime, C prime, D prime, E prime. A translation up 4 units followed by a rotation 90 degrees clockwise about the origin, a rotation 180 degrees clockwise about the origin followed by a reflection in the x-axis, a rotation 180 degrees clockwise about the origin followed by the reflection in the y-axis, and then a translation 4 units up followed by a reflection in the y-axis. So this one seems like it would, since I know translations and reflections are my strengths, and they're the easiest for me to do, I would just start actually here. Translation up 4 units. Now I'm going to ask myself, is a translation and a reflection is a translation and a reflection a rigid transformation? If the answer is yes, that means we can check 1 point and be finished if it matches or if it doesn't match. The reason for this is because a rigid transformation protects the side lengths, preserves side lengths, and angle measures. So it just pretty much picks up this image, moves it around, and keeps it. It doesn't change the length of the sides. So that's why I can check just one of these points, because if the distance from A to B stays the same, and I know that point A was either moved correctly or incorrectly, that means that this distance would be the same, so either B would be moved correctly or incorrectly as well. So I'm going to start with my strength, which is a translation 4 units up followed by a reflection in the y-axis. So if I were to translate point A up 4 units, it'd be 1, 2, 3, 4. So this is where A would be after translation up 4 units, and then a reflection in the y-axis. So here's our y-axis. And since this A is 3 units to the left of our line of reflection, it will now be 3 units to the right of it. And that does end up being right at A prime. So that is our option. I hope that helps explain why I did what I did.